Okay, G fields, gravitational waves. This is something you're probably going to learn when we get to year 13 physics, okay? But if you're in year 12, it's good to learn about it right now, so you've got a quick intro for it. What we're going to go over is what are G fields. Gravitational fields, we know a gravitational field or gravitational field strength can be defined as the force per unit mass, okay? So what we know is that anything that has mass is going to have a force on it. So we can draw the direction of our gravitational field lines. What our gravitational field lines are, they show us the direction of that force on the mass. Okay, so what I imagine is, I got a unit mass. So unit mass could be like a 1 kilogram mass. Let's say we got some mass here. So our gravitational field lines shows the direction of that force on that mass. Because remember, gravitational field strength is force per unit mass. I know things with mass are always pulled together, because we know that gravitational fields, or that force of gravity, is always an attractive force. Okay, so it always pulls things together. So this mass is going to get pulled towards the big mass of the Earth. So what's going to happen is it's going to move down towards that Earth. If I put the mass over here, again, this mass, this unit mass, is going to get attracted towards the Earth. So it's going to move in this direction. If I put the mass here, again, it's going to get attracted towards the Earth, move in this direction. So what you can see is that no matter where we put the mass, it's always going to move towards the center of the Earth. And that's why then we can see what the gravitational field lines look like around a planet, right? They look like the spokes of a tire. They always go inwards towards the Earth because masses always get pulled in towards the center of the Earth. However, because the Earth is so large, on the surface of the Earth, we can model it as uniform. So we can say that if I had a mass here, then what's going to happen is it's going to get pulled down towards the center of the Earth. If I have a mass here, what's going to happen is it gets pulled down towards the center of the Earth. If I have a mass here, what's going to happen is it gets pulled down towards the center of the Earth. So that's why we can model it as uniform on the surface of the Earth, or close to the surface of the Earth, because the Earth is so large. Okay, so that's why we can model G on the surface of the Earth. It should end up using that number of 9.81. So yeah, some of you might use 10 in GCSEs, some of you might use 9 in GCSEs, but now we're going to use 9.81. Sorry, use 9.8 in your GCSEs. So now we're going to use 9.81. We can also figure out what actually is the force between two objects with mass. So again, I have a mass, the Earth has a mass, there will be a force of gravity pulling me towards the Earth. In Newton's third law, I'm also pulling the Earth up. But I'm the one that's seen to move because my mass is much lighter. And we can figure out what that force is between two masses. That force is going to be equal to G, which is our universal gravitational constant, which one I'm going to use is 6.67 times 10 to the power of -11. So on your formula sheet. So that's our universal gravitational constant. Multiplied by the mass of 1, so object 1, so it might be the Earth. Multiplied by